Okay, so my name is Ashwani Yadav. I am M.Tech from iiest. Okay, so we are doing some illustration over Faraday law or electromagnetic induction. So let us proceed again with some beautiful revision of questions. So so we have a conductor, pi shaped conductor. This is question is pi shaped conductor. I am not going to write the whole question. I would like to recite this and try to make you understand what the question is saying. Okay, so a long straight, here is a long straight wire. This is a wire carrying a current I and a pi shaped conductor with a connector. This is a connector and this is a slider. It can slide and have length is L. Okay, and resistance R. It slides with a constant velocity, and resistance is R, and slides to the right side as you are depicted in the picture. Resistance of pi shape neglected. Also neglect self-inductance of the loop. Self-induction of the loop. Please neglect this. Now, what is the current? Question is, what is the current produced in the loop? What is the current produced in the loop as a function of R between the connector and a straight wire? So R is the distance between connector and this straight wire. In a function of R, you have to find the current induced, okay, in this loop. This is your question. So well, let us do this. This is a very good question. Not very good question, just to understand the core of core of the question, how it is asked and what is the purpose of this and how to solve this. Then it's very easy. Okay, so in this space it will produce magnetic field inside the surface, and you can say that B is equal to mu epsilon naught I, say I, with respect to x distance. You can say x or r. Okay, now what is the flux? Here you can take this ds, okay, small elementary area, this one like this, ds, and ds is L into dx. Then flux is nothing but B dot n unit vector. So just I am going to write flux of this quantity n unit vector ds, and so it will vary from 0 to r. So b we have mu epsilon naught I 2 pi x L dx 0 to r, because we have to find flux with respect to r, because this is going to be vary up to r. So now we have flux is equal to, just solve this, mu I L 2 pi ln r okay. So this is your flux and this is varying with function r. So rate of change of flux, you can find EMF is equal to rate of change of flux. We can have to check its sign. What I can consider here its magnitude. So time differentiation of this quantity will give you the EMF, and its value is mu I L 2 pi ln r differentiated as 1 by r and dr by dt, and dr by dt is velocity of this slider. So now we have EMF L 2 pi r into velocity. So current EMF by r. R is the resistance of the slider. Okay, as I have mentioned earlier while reciting the question R. Okay, so this is the current produced in this loop. Okay, so another question, another examples based on this same concept, but having little modification, that we have current source this is source of magnetic field, current carrying wire, and now we have a square frame. This is a square frame. Every side is equal, and it has velocity v right towards right. Now this distance is r. Now find the EMF induced in the loop as a function of distance r. Okay, this is your question. This is the basic question. I will give you a lot of question, advanced question asked in IIT Advanced, but I have to go step by step, some basic, thereafter good question, some questions from advanced, and some questions from irodov. So I will mix this concept to grow you up. Okay, again you have to take this, as like I previously have discussed, this elementary area ds, and this is a dx. Suppose this length is x, as previously I have discussed, this length is small dx. So ds, then b is mu epsilon naught I 2 pi x. This question is very much similar to the previous one. So flux is b integration of dot ds mu epsilon naught I by 2 pi x a dx and x is varying from, this is your distance r to r plus a. So flux, you can find after evaluating this integration. So you have, okay, I can write directly because it's a very easy one. 2 pi logarithm ln, put this value, you will get this. This is very simple. Okay, it's a flux. Now time derivative of this flux magnitude will give you EMF, and differentiate it, you will give mu epsilon naught I a by 2 pi one by r plus a minus 1 by r and dr by dt. This is the velocity of this frame. So we have mu epsilon naught IA 2 pi 1 by r plus a minus 1 by r into v. Okay, this is the EMF. Now another examples is that a conducting rod, suppose this is a rod, conducting rod OA of OA, this is rod of mass m, it is rotating, okay, it is rotating about the horizontal axis O. It is rotating like this about a horizontal axis. That is a horizontal axis. This means this OA is in vertical plane. So there must be a gravitational force will act on it. Okay, gravity will come here because of this vertical displacement from the earth. So horizontal axis, this explains that there must be a gravitational force acting on this one, and a source of current. Okay, just give a source of current to it. Okay, this is a source of current, and there is a magnetic field directed towards inward perpendicular to the ring. This is the ring, and of course you have to give resistance, that is the R in a usual unit. Then you develop equation of EMF in such a way that it vary source. Okay, now question is that find the law according to which source EMF must vary to make the rod rotate with angular velocity omega. Okay, find the law according to which source EMF may vary to make the rod rotate with angular velocity. This means torque due to magnetic force and torque due to weight should be balanced to each other. If anyone is more, then there is some angular acceleration and omega will not be constant. Okay, to avoid angular acceleration, torque acting on this rod should be balanced, and two forces, keep in the mind there are two forces here, magnetic forces. And do you know what is the EMF generated? You know this, what is the EMF generated? Potential difference generated between the rod when it has rotated. It has a length L, so we know that half B omega. Length is, say length is A, half B omega A square. This is the amount of potential difference created between the 2 points if it has rotated like this angle omega theta. And we know that if you rotate it like this, then you have to find the polarity. It is rotating like this, so this is your X and this is your Y. So this is point O and A, and velocity is in this direction. So you will find A is higher polarity. We have already done this. So A is at higher polarity, so current will flow in this direction to A to O. So current will flow from A to O because A is at higher polarity. And how we will find the polarity EMF? We have B cross B dot dl. We have done this operation and find what is the EMF, what kind of quantity. Is it with okay with that direction? Then it has a positive sign along dl. Okay, so let us do this if you want to do this. Okay, so V velocity, X, and here is Y, and this is Z. So velocity is coming like this. Velocity every element is like this, rotating. So you can say this direction is in vector k. Okay, so if you consider Y, then velocity is like this, or negative j, you can consider this, then k is minus k dot dl is I, then I j k, j cross k is I dot I, it is a positive quantity. So in this direction you are getting a positive things. Okay, so it is well behaved with this operation. So we have this quantity as a positive one and this one as a negative one. So we can find this polarity. Okay. So now we have found this one. Then current is half B omega A square by R. Because why we have found the current? Because we need to find the magnetic forces. Okay. And this is the current. And you know the force, magnetic force, is nothing but I dr I cross dl cross b. This is in vector form, and we know that this one is perpendicular to each other, so we can write current dr and b. And d tau, this is the torque. We have to balance the torque because motion is angular motion, so we have to consider this one. Equation of motion will be discussed by torque. So I dl b into r. This is the r is any distance from this point. Okay, this is the tau. What will you get? B omega A square by 2 R dr into B and B area square, and this is from 0 to L over this length. Okay, so we have d tau integration, it will give the torque b square omega r square, then a to the power 4 by 2. We are missing r here, 2 into 2r, so we have torque equal to 1 by 4 b square omega a4 by r. Okay, so this is the torque due to the force or magnetic force, because it is a conductor rotated, motional EMF will produce, and hence current thereafter forces, and then torque we have calculated. This much torque will act on it. Okay, now torque due to the weight. Torque due to the weight here mg force will act on it. Now torque due to weight. Okay, torque is, and this distance is like this, O A, and mg will act like this, and this is the distance we want to know, and this is 90 minus omega theta, as this is omega theta. So we have torque distance, this distance is a by 2 cos sine omega t. So we have force and perpendicular distance is a by 2 sine omega t. We know that what is the torque. Force point of application is this one. So force, just direction of the force is this one. So just draw a parallel line and you just calculate the distance, perpendicular distance between the two lines. This is your arm length. So force into arm length is the torque. And do you know the direction of the force due to this current? It was also in the same direction, like this. Force dF was acting like this. Okay, so both torque are acting on the same direction. So net torque, you just calculate direction of the force, I into L cross B, like this. Current in this direction minus I, L minus I is length, current L minus I cross K, I j K, I cross I, this is the negative, j negative 1 minus j. Okay, this is a positive one here, upside. So negative means downward, it has a tendency to move downward. Downward means in this direction, coming down like this, going up in this direction, there must be positive z. So I minus k, because it is going in this direction, so we have forces in this direction. Okay, we have calculated force in negative z, and gravity forces is acting downward too. So both torque are acting in same direction, downward. So we can write torque, net torque is, just add this, mg a by 2 sine omega by 2 plus half b square omega f4 by r. This is the net torque acting in this direction. So there must be another force to keep this omega torque is acting. So there must be an angular, due to thus angular velocity. So to keep this angular velocity, equal amount of torque will act opposite to that one. Okay. So why this torque will produce again? Because of this current. So current produced by the battery is suppose will be E by R, because E is the external EMF. Okay, this is another additional source of current. And when there is a current in a conductor and put in the magnetic field, force will act on it, and force, since this is rotating, so we have to calculate the torque and balance this one. Okay, then you are able to find answer EMF, suitable answer. Okay, we are very much close to the answer. So evaluate this. So small df is equal to I drb. As usual, E is equal to ER drb, and now torque is df E by R drb. So E B R R dr 0 to A. So we have E B A square by 2r, and this is the torque, tau dash, and tau dash okay, well, so I am very close to the answer. This 2 tau dash must be equal to each other, so EMF just divide by this quantity this side, we will get the answer. mg r by ba sin omega t plus half b, 1 is going to be cancelled, b omega a square, r is going to be cancelled 1. Okay, so this is the EMF, so that it can balance the torque. Okay, let us do the next problem. Okay, now next problem is, we have inclined this is your inclined conducting bar, inclined at angle theta, and we have a rod of mass m. This has a rod, this resistance is r, and this magnetic field is like this, and this is mass m, and his length is l, and setup is placed in uniform magnetic field perpendicular to the plane. This is perpendicular to the plane, b is perpendicular to plane. Then find the steady state velocity of the rod. Find the steady state velocity of rod. This is your question. Okay, so it's inclined, of course. We have one forces, you can write this one, and here magnetic forces will act on it. We know that EMF due to motions, it is V B L. B is given B L. So now current is produced in this loop is V B L by R. This will act as a battery whose EMF is like this one. If it has a velocity v, then force is ILB. So we have ILB, B square L square V by I. This is towards incline. Okay, this is in this direction F. This is magnetic force, and one other is due to gravity. Now a steady state velocity just balance two forces. Okay, what happened with respect to time? Also you can calculate mg sin theta b square L square v by r. Now we have v is equal to mg r sin theta b square L square. But sometimes you need to find the velocity variation with respect to the time. Then how will you find this? Okay, just develop a general equation of velocity variation with respect to time. Okay, so using the Newton's law of motion, second law of motions, I can write that downward forces is mg sine theta minus magnetic forces we have calculated of b square l square v and into r as this is the net force, and Newton from law of motion this net force is equal to m dv by dt. Okay, so we have now equations. Now we have dv by dt plus, because velocity is in this direction, b square l square v r m and is equal to g sine theta. This is your differential equation. You know the integrating factor. No, due to the integrating factor, this is first order differential equation. This coefficient integrating factor is e b square l square by mr. This is the integrating factor. Multiplying with both the side, you will get v dot e to the power p square l square mr is equal to g sine theta e square b square l square mr dt integration. So we can solve this. So we can solve this as v is equal to exponential is okay. It's a very easy one. mgr sine theta, just divide by this quantity in the integration b square l square, then mgr b square l square e to the power b square l square mr into t, okay, plus c. Okay, this is your v e to the power b square l square by mr, and t is equal to 0, b is equal to 0. Initially at boundary condition we have t is equal to 0, b is equal to 0. We put this, you will find this will be becoming 0 to the power 1. Then c is equal to, because this will be 0 and t is equal to 0, it becomes 1. So c is equal to minus mgr sine theta b square l square. So you have find this constant quantity. Now okay, just put this value. Okay, now you have answer. So let me rub this from upper side. Oh sorry, but I have calculation. Okay, so I know what is the calculation, so I can easily write again. So now we have v e to the power b square l square. This was the calculation. mr is equal to mgr sine theta b square l square e to the power b square l square mg r minus mg r sine theta b square l square. So v e to the power b square l square mr is equal to, so what is the constant here? mgr sine theta b square l square e to the power b square l square mr minus 1. So divide this side with these equations, put it here, we will get mgr sine theta b square l square 1 minus 1 by this one, this means e to the power minus m square l square mr. This is your answer, this is the velocity, okay, with this, okay, sorry, with time, here time, okay, so this is your equation. Here also time, because integrating factor was this one. Sorry if I missed any term, okay, it's just up to you, you can understand this. So this is your velocity with the function of t, and do you know the nature of this graph? The maximum value is this one, maximum v max, okay, v max is this steady state mgr sine theta b square l square. So how this maximum velocity is growing with time with this one? It has grown, it has taken certain amount of time to reach this maximum value, okay. So slider has taken some amount of time to reach the maximum velocity, you can say this is the maximum. And you know the graph, general graph, you know, this is like this exponential, so we have velocity versus time, v is equal to 0, it is go like this, and maximum will okay, so we have maximum mgr sine theta b square l square, this is the maximum velocity, no? So this is going like this at t barabar 0, at t barabar t. Okay, thank you. In next class again I will do the problems ahead. Thank you.